Hello and good morning everyone. How are you all? So, so in this video we will be discussing the most important previous year questions of JEE Mains. You guys are going to write the NEET exam, JEE exam. So, solving the previous year question becomes of utmost importance. Okay, you have solved the question, you have revised the concepts. Now you have to practice it. So through this video, you can just go through the questions, what type of questions they are asking, and almost all of the previous year questions of this chapter will see in this video, or maybe one or two parts will be there, but I will cover every single question of the previous year question that JEE have asked. Okay, so let's start with this question. So the question says that we have a positive ion and a negative ion B. So two ions we have, positive and negative. Charges are given, masses are given. Okay, at any instant separated by a distance r, at that instant the ratio of magnitudes of electrostatic force to gravitational force. So they are asking electrostatic to gravitational. Okay, electrostatic upon gravitational ratio. So electrostatic force is 9 into 10 to the power 9 q1 q2 product of charges upon distance square, and this one will be g, and g value is 6.67 10 to the power minus 11 g m1 m2 product of the masses m1 m2. So after doing all this one, it should come out to be half into 10 to the power 45. So okay, let's see the next question. Small uncharged conducting sphere is placed in contact with an identical sphere. Uncharged conducting sphere is placed in contact with identical sphere having charge this much, and then removed to a distance such that the force of repulsion is 9. The distance between them is, okay, so 4 into 10 power minus 8. Initially force is how much between them? Initially charge is 4 into 10 power minus 8. When they will be placed in the contact, charge distribution will take place, and such that the equal charge distribution will be there, q by 2 and q by 2. Okay, so this one will get 2 into 10 to the power minus 8. Both of them will get this charge. Okay, force between them is how much? 9 into 10 to the power minus 3. So 9 into 10 to the power minus 3. Force will be equals to k q1 q2. So after multiplication, 4 into 10 to the power minus 16 upon distance square, r square. So 9 cancel, r square one side, this is 4 into 10 to the power minus 16 and 10 to the power minus 3, so 10 to the power minus 13, and then plus 9, so 10 to the power minus 4, so it will become 2 into 10 to the power minus 2 meter. This should be the distance between them. 2 into 10 to the power minus 2 means 2 centimeter. Got this problem? Okay, let's move forward to the next question. Force between 2 point charges q1 and q2 placed in vacuum at r is F. 2 point charges at some distance, force is F. Now when placed in medium having dielectric K equals to 5, the question is saying that what will be the force between them when dielectric medium 5 and r by 5. Okay, so simple, we know that force in vacuum is there divided by K, that will be our force in medium. This concept you have to remember. I hope you remember, that's a very easy concept, right? Force in a given medium will be given by vacuum force divided by dielectric. Now see the question. Here vacuum force is F, so dielectric force should be how much? F by 5. But distance also becomes how much? R by 5. So distance becomes R by 5 and it is proportional to 1 by distance square. Force is proportional to 1 by distance square. So when distance becomes 1 R by 5, force should become how much times? 25 times. So now original force F, because of the medium it will become F by 5, because of the distance it will become 25 times. So our answer will be 5F. Clear? Which option? Option number B. Okay, next question. Identical charge spheres suspended by strings of equal heights make angle theta. When suspended in water, angles remain same. Density of the material is this one. Dielectric constant of the water will be. Okay, now mark it down, very important question. There was a time when this question was asked in JEE Advanced. So after that, now it is being asked in JEE Mains, even in NEET also they will ask this question. Okay, let's see what the question is asking. So we have two identical spheres, angle between them is theta. Okay, so when we are placing them in a medium in water, angle does not change. Okay, let me just give it a little bit like this. Okay, so when placed in liquid, angle between them does not change. So what is the value of dielectric constant? So let's see. If you draw the free body diagram, downward force will be mg, this side force will be electrostatic. Okay, I think I need to adjust it a little bit. Let me just adjust it. Okay, okay, downward force is mg, this side force is electrostatic Fe. Same on this one, and on this thread there will be tension. Okay, this one is electrostatic force. Now if you talk about in this second case, it is everything is in liquid. So let's draw the free body diagram. Downward force will be mg, no change. This side force will be how much? Fe, no, Fe by k, and one more force upward, that is buoyant force. Clear? Now let's see. Tension will also be there in this string. So if you talk about this angle theta, this angle also theta. So break the component of tension. This side t sin theta and this side t cos theta. Equating the forces. So t sin theta will be equals to Fe and t cos theta will be equal to mg. Okay, so from here we'll get tan theta. Tan theta will be Fe by mg, equation number 1. Now let's see the same thing for the second case. For the second case, if you break this t, this side it will come t sin theta and upward it will come t cos theta. Equating the left side force and right side force, so both forces will be what? Equal. So because of equilibrium, t sin theta will be equals to Fe by k and t cos theta will be equal to mg minus buoyant force, equation number 2. Divide both of them, we will get tan theta again. So tan theta will be equals to Fe upon k times mg minus buoyant force. Since angle is not changing, so equation number 1 and equation number 2 are representing what? Same thing. So we can say that Fe upon mg equals to Fe k times mg minus buoyant force. Okay, so Fe cancel. So you'll get that mg equal to k times mg minus buoyant force. So let's see buoyant force. Buoyant force will be given by volume of the liquid displaced, and that will be the volume of the sphere. Sphere, whatever volume it has, same amount of liquid it will displace. Like this one, no? This sphere has some volume, so that amount of liquid it will displace. So volume into density, mass, density of liquid into g, mass into density, that is the force. Okay, now mg, see the mg. So mass of the solid will be given by volume of the solid ball into density of the solid into g, equals to k again v rho s into g minus v rho l into g. After combining, we will get the value of k directly, rho s upon rho s minus rho l. Okay, mark it down, important. It is applicable for this question only. So directly you can remember the value of dielectric constant, solid density upon solid minus liquid density. That is will be the value of dielectric constant. Okay, so let's see the answer now. Suspended in water, angle the density of the material is sphere, the dielectric constant will be 1.5. So dielectric constant will be sphere upon sphere minus 1. So how much it will come? 3. Water, how much? For water, how much density? 1. Okay, 1 gram per cc. So that will come out to be 3. So dielectric constant of this water will be 3. Okay, Very important question. See it again, mug it up, but remember that. Next question. We have here, okay, identical charge spheres suspended by a string of equal lengths. String makes angle 37 degree with each other. Suspended in a liquid of density, angle remains same. Density of the material is 1.4. Now again same question here. See one concept I have given you. So in this kind of cases, rho will become dielectric constant will be rho solid upon rho solid minus rho liquid when angle does not change. Solid is given 0.7 gram, suspended in a liquid of density is given, and this is also given. So solid is 1.4 upon 1.4 minus 0.7, so it will be 2. What will be the dielectric constant? 2. Okay. Okay, so let's move towards the next question. So what the next question is saying is that we have a metallic wire, cross section area given, used to make a ring of radius 30 centimeter. Okay, positive charge 2 pi c uniformly distributed over the ring. Another positive charge 30 picocoulomb kept at the center. Tension in the ring is, okay, tension in the ring, provided that the ring does not get deformed. Influence of gravity neglected, 1.4 pi epsilon naught. We can put this. From the center we have placed a charge, let's say capital Q charge is there on the ring. Okay, if you analyze a small elemental section, magnify, we are magnifying it and we are analyzing this small section of the boundary. So for this small section we can say that, let's say it is making angle 2d theta at the center. Okay, so now in this end we will have tension T, similarly we will have tension in this end T. So if from the center if you draw the line, this angle will be d theta, other angle will also be d theta. Draw the vertical line, so this angle d theta, so this angle 9, this angle d theta, 90 minus d theta, so this angle again d theta. So break the component of tension along this side, so it will become T cos d theta, and this side T sin d theta. Similarly this component by symmetry here it will come T cos d theta and downward T sin d theta. Charge at the center will apply a repulsive force on the ring, electrostatic force. Now see this one already cancelled. This T sin theta, it will become 2T sin of d theta, that will be compared with what? F. Okay, now 2T sin of d theta, that will be F. See F will be K, Q small q capital Q divided by R square. So 2T sin d theta equals to K small, capital Q will be given by capital Q is basically charge on this one, okay, not the total charge but charge on this one. So charge on this one will be, just to avoid the confusion, let's write it as Q dash. So Q dash means charge on the elemental part of the ring, this much. So that one will be given by total charge upon 2 pi r. This is charge density, charge per unit length. Q charge is distributed over the 2 pi r length. So Q upon 2 pi r into, what is the length here? So r angle 2d theta. So length will become radius into angle, r into 2d theta. So r into 2d theta, that is our charge upon r square. Okay, let's see. See here sin d theta, since theta is very small angle, so sin d theta and d theta will be equal. So 2 sin d theta and 2 d theta, they will cancel. So we'll get that T equals to K capital Q small q r and r. So it will be given 2 pi r square. So K value 9 into 10 to the power 9. Now let's see. So tension is coming to be how much? K capital Q small q upon 2 pi r square. Okay, 9 into 10 to the power 9. Capital Q is 30 pico, 10 power minus 12. Small q is how much? 2 pi upon 2 pi. Radius is square, radius is 30. So 30 into 10 power minus 2, 2 pi cancel. Okay, 30 one times cancel, one time will remain. So here 9 into 10 power minus 3 upon 900, sorry, 30 will remain. 30, 130 cancel, so 30 will remain, 10 to the power minus 4. So 90 upon 30, that is 3 Newton. Okay, important question, mark it down and remember it. This derivation is important. How we derive the value of tension, K capital K small k over 2 pi r square. So ring tension directly you can remember. Clear? Okay. Okay, so let's see the question number 7 now. It is saying that uniformly charged wall is there. Okay, uniform electric field it provides normally. Particle mass 2 gram suspended through silk thread 20 centimeter, remain stayed at distance 10 centimeter. Okay, let's see the diagram. This is the wall, this is our block 20 centimeter, and this one 10 centimeter away from the wall, it remains suspended, mean equilibrium. So downward force will be how much? mg. This side force will be how much? QE. This angle is theta, so this angle will also be theta, and this string there will be a force called tension. So if you break the component, so T cos theta will be equal to mg and T sin theta will be equal to QE. So dividing both of them, tan theta will be equal to QE by mg. Okay, now if you take this length 220, this 10, so this one will come root over 300 using Pythagoras theorem. So tan theta will be how much? 1 by root 3. 1 by root 3 equals to QE by mg. Okay, so from this one we can directly write down the value of Q. So Q value will be how much? mg upon root 3 into E. So mg, mass 2 grams, 10 power minus 3 into 10 upon root 3. Electric field is how much? 2 into 10 power 4. So 2 into 10 power 4. So it will become 1 by root 3 10 to the power minus 6. Okay, so x value is how much? Root x value is 3. This is our answer. Okay, simple. Okay, so this question you have to remember that electrostatic force upon gravitational force between proton and electron. Proton and electron is what order? 10 to the power 39. You can calculate it, the simple calculation is there, but it will take some time. So for proton and electron as well as electron and electron, you remember this force. Which force will be more? Electrostatic or Coulombian force will always be more than gravitational force. Next question. Identical conducting spheres PS, charge Q on each. Okay, two identical we have, both of them having charge Q, repel each other with how much force? 16 newtons. So both of them are repelling each other with 16 Newton force. Third, identical uncharged conducting sphere successively brought in contact with the two spheres, the new force of repulsion will be. Okay, simple. Again, let me tell you what the question is saying. We have identical spheres, both having Q charge. We have uncharged third identical sphere. We are first connecting it with this one. So what will happen when you connect two identical spheres? When we connect two identical spheres, one thing you have to remember, that potential will become constant, and since they are identical and potential has to be constant, so charge will also be equal on both of them. So total charge, here we have Q, here we have nothing, so total Q. So how much they will get? Q by 2, Q by 2, both of them will get. Okay, now this identical sphere is going in connection with this third one, so again total charge will be Q on this one and Q by 2 on this one, 3Q by 2. So both of them get how much? 3Q by 4 and 3Q by 4. So this charge came and now it has gone. Original force between them was 16. Now it will become how much times? See here, charge, this charge has become 1 by 2 times. This charge has become 3 by 4 times. So force will become how much times? 3 by 8 times. Got it? Charge becomes Q by 2 times, 3Q by 4 times. So total force will become 3 by 8 times. Original force was how much? 16. Now it becomes 3 by 8 times 16. So how much will remain? 8 to 6 Newton. This is the final force between the two conducting spheres. Which option? Option number B. Clear? Okay, let's move to the next question. Two charges Q1, Q2 separated with D are placed in a medium of dielectric K. What will be the equivalent distance between the charges in air for the same electrostatic force? Okay, let me again explain it on a blank page. So there are two charges are there, Q1, Q2 in dielectric medium K, distance D. So force between them will be how much? K, Q1, Q2 by K1, sorry, here you write it like this, 4 pi epsilon naught K into D square. This is the force between them. Now the question is saying that the force remains same between them. Force is not changing. So at what distance you will keep them in air? So in air force will be how much? Q1, Q2 upon 4 pi epsilon naught and D dash square. Distance is D dash. So if force does not change, for both forces equal, after comparing it you will get that KD square equal to what? D dash square. So at what distance you will place root K times D distance. Okay. At this distance you will place them in air so that the force will not change. Root K times D, first option. You have to be very careful with the options also. See, K root D, D root K. If you are able to solve and get confused with this one, then it's your bad luck, man. Okay, let's see question number 11. We have here 10 Coulomb charge divided into two parts placed at 1 centimeter so that the repulsive force between them is maximum. They are simple, there is no need of confusion here. If you are breaking any charge, Q charge, such that force between them is maximum, so how much should you break it? You should break them equally. Okay, Q by 2, Q by 2. So 5 Coulomb and 5 Coulomb. Whenever you have to break one big charge into two different charges, into two charges, such that the force between them remains what? Force between them becomes maximum. So how would you break them? You will break them equally into two parts. Clear? Okay, next question. We have 3 point charges placed on the x-axis, 0, 3 by 4 are R. Q value is given, R value is given. The magnitude of net force experienced by the charge minus 2Q is. So how much this minus 2Q is experiencing the net force? Okay, let's see. This one will attract toward this side. So by what? 2Q square by 3 by 4 R square means 9 by 16 R square. This side force will be how much? 4Q square K upon distance is how much? R by 4. So R square by 16. Okay. So here 32 by 9. This one. So I will take common. This force seems to be more than this one force. So resultant will be difference. Okay. So K into 16 Q square by R square common. So it will be 4 minus 2 by 9. So let's see the calculation. Net force will become K or 9, 16 Q square. Charge is given 2 Newton per minus 6. So 4 into 10 per minus 12 Q square upon R square. Radius is given how much? 2 centimeter. So 4 into 10 power minus 4 and one constant 36 minus 2, 34 by 9 to 34 by 9. So 9 cancel. Configuration of two equal point charges, 2 microcoulomb charge, 20 gram mass, friction is not there. Okay, equilibrium, both are in equilibrium, then value of H will be. Okay, so now we need this H. So downward force will be there, that is mg. Both are equal charges, so it will repel in this direction, that is electrostatic force, and this one perpendicular normal. If this is 30, so this angle will be 60 degree. Now breaking mg in this direction, so it will become mg cos 60, mg by 2. taking in this direction, it will be mg sine 60 root 3 by 2. So Fe will be equal to mg by 2, electrostatic force. So k q naught square upon distance is h. So this distance will be h cosec 30, h cosec 30 whole square. Here using trigonometry we can find out this distance between two charges. So h cosec 30 whole square kq square by r square, that will be equal to what? mg by 2. Let's see the value. H square will go this side. So h square equal to kq square 9 into 10 power 9 into charges given how much? 2 microcoulomb, mass 20 gram. So charges 2 microcoulomb. So 4 into 10 power minus 12 upon cosec 30. So sine 30 is 1 by 2, so square it will become 4. 2 will be multiplied this side, mg will be divided. So mg is 20, 10 power minus 3 into 10. So after solving you will get this one cancel, 10, 10. So okay, 10 power minus 3. So this one cancel, this one 2 cancel, 10 power minus 2. So you'll get the 9 into 10 power minus 2. So answer will be how much? 3 into 10 power minus 1 meter. So it is 30 centimeter. So this is our answer for this problem. I hope calculation is simple. What we are doing, you are able to get it. Okay. Equal positive point charges are separated by a distance 2a. We have equal positive point charges to a distance of point from the center of the line joining two charges on the equatorial line perpendicular bisector, at which force experienced by test charge becomes maximum. Okay, so now this you can solve it also, or you can just remember it from the ring. Okay, you can establish the analogy from the ring. Two equal point charges q and q. From the center you are going at distance x. So x will be this distance between them, 2a. So for maximum in ring, the ring is how much? X equals to r by root 2. So r means this one, a. So a by root 2. So x will be how much? 2. Okay, simple analogy with the ring. If two charges are there, four charges are there, from the center they should be at the same distance. This is at distance a, this is also at distance a. So both of them will be called what? Radius. Take multiple charges, keep on taking, r by root 2 will be the maxima. Okay. Okay, let's move on to the next question. We have here point charge 4q0 placed at origin. Another point charge minus q0 12 centimeter. Charge of proton is q0. Proton is placed on the x-axis so that the electrostatic force on the proton is 0. Position of the proton from the axis will be. Okay, simple, very simple, easiest question, man, I will tell it. Okay, let me just remember, see the charge 4q0 minus q0 12 centimeter. Okay, so we have here charge 4q0 minus q0, radius between them is 12 centimeter. Position also you notify. 4q0 point charge is placed at x equals to 12 centimeter. Okay, so this is 12 centimeter. Now this is our origin. Okay, now they are asking where should you place a proton charge q0 so that net force on it will be 0. So see, this is plus, this is minus. When charges are unlike, then you place either left or right. Equilibrium point will be there, either left or right, when charges are unlike charges. And in that too, what you have to remember, if the charges are unlike, then equilibrium left or right and closer to lesser charge, magnitude wise, only magnitude wise. So it will be closer to lesser charge. So here lesser charge is which one? Minus q0. So equilibrium point will be a distance x from this one. Okay, you place q naught. Now calculate the force on this one. This one will give it this side force. It will be k q naught square by x square, and this one should give 4q will give this in this side direction, k 4q q naught divided by 12 plus x whole square. So k 4q q naught 12 plus x whole square. So k q naught 4 q naught both are there, no, 4 q naught. So q naught square will also be cancelled. So 1 by x square equals to 4 upon 12 plus x whole square. Now take the root. 1 by x equals to 2 upon 12 plus x. 12 plus x will be equal to 2x. So x will be how much? 12 centimeter. At what distance you will place 12 centimeter from this minus q naught? Q naught is already 12 centimeter, so its coordinate will be 24 centimeter, comma, from this origin it will be at what distance? 24 centimeter. Clear? Okay. Let me just put some more emphasis on this one. Trick point, what you have to remember: if two charges are there, q1, q2, if both of them are like charges, then equilibrium will lie in between. Equilibrium will lie in between. So suppose the equilibrium is at distance x. So x value will be given by root q1 upon root q1 plus root q2 plus q1 into distance between them, d. Okay. If they are unlike charges, positive, negative, unlike charges, then equilibrium point will be either left or right and lesser charge. Closer to what charge? Lesser charge. So suppose you are talking in that case x, you will take either left or right. Let's say q2 is less, so x distance you will take from the q2. So x will be given by root q2 upon root q1 minus root q2 into d. Okay, and now you can apply this trick in the above equation again. So this is method number 2, trick method. So what we can do here we can calculate x by formula root q naught, magnitude wise only, root 4 q naught minus root q naught into 12. So it will come out to be c root q naught 1 upon 2 minus 1 into 12. How much it will come? 12 centimeter. Okay. So if you are able to remember this trick, that is very, very useful for this type of questions to find the equilibrium point. अगला क्वेश्चन देखते हैं, क्वेश्चन नंबर 16. Identical positive charges fixed at 2a from each other. Another point charge q naught with mass m placed at the midpoint. Small displacement along the line fixed joining the fixed charges. Q naught executes SHM. So time period of oscillation of charge q naught will be. Let's see the solution then. We have charges q and q at distance 2a. Center we have a charge q naught comma m. So this q naught is being displaced this side, x distance. Distances are given or not between them? Let me check. 2a apart. Okay, 2a apart. So a little bit displaced this side. So now charge is present here. So that's left side one will push it toward the right side one will push it toward the left side, but net force will go towards the right side. This one will be more, so F net will be towards the right side. F net will be how much? K capital Q small q naught, distance between them a minus x whole square minus k q naught, distance between the charges a plus x whole square, k q naught 1 upon a minus x whole square minus 1 upon a plus x whole square. Now a square plus x square plus 2x minus a square minus x square plus 2x upon a square minus x square whole square. Okay, so see here, a square x square cancel, 4x will come. So k q naught into 4ax upon, now a is very, very large as compared to x, so it will become a power 4. Q naught A will cancel with A, so 4 will cancel with here pi epsilon naught AQ. This is our net force. Equating this net force with what? M omega square. So we'll get that M omega square equals Q naught upon pi epsilon naught AQ. So omega will be root over Q naught upon pi epsilon naught M AQ. So time period will be 2 pi root over omega pi epsilon naught MAQ by Q naught. Now everything inside, so it will become 4 pi Q epsilon naught MAQ Q naught. So this will be our answer. Option number 1. Clear? Okay. Let's move on to the next question. Identical metallic spheres A, B placed at certain distance in air, repel with what force? F force. Identical metallic spheres A, B placed at certain distance in air, repel with F force. Another unidentical uncharged sphere C placed in contact with A and then in contact with B. So finally placed at the midpoint between A and B. The force experienced by C will be. I think this type of question we have already done. So you give it a try. Okay, in the start only we did this question. Now when we are touching two spheres, charge distribution will take place. Total charge by 2. Both of them will get half of the total charge. So do the derivation and comment the answer. Okay, next question. 2-point charges Q placed at distance d apart. Third point charge placed at distance x from the midpoint. The value of x for which Q will experience maximum. Okay, maximum Coulomb force. Now see, these questions are getting repeated. Q charges are placed at what distance? D distance apart. So if you talk about from the center, this Q charge from the center, this distance is d by 2. This distance will be d by 2. Now comparing it with the ring analogy, radius of the ring will be what? D by 2. So what is the distance for the maximum force, maximum field? Radius by root 2. So d by 2 root 2. So d by 2 root 2. Answer D is the option. Okay. As I am telling you that analogy, these kind of questions, that as it is you have to practice. Question number 19. Identical uncharged particles, mass given, charge given, placed on a horizontal table, separation L. They stay in limited equilibrium. Coefficient of friction between the table is 0.25. Find the value of L. Okay. So the charges are there, Q and Q, L distance. So we have here electrostatic force and here mu into normal friction force. Equilibrium means both forces should be equal. So electrostatic force K Q square by L square, that will be equal to mu into normal, that is mg. So what is the value of L square? So L square will be how much? KQ square, 9 into 10 to the power 9 K. Q square, both charges are how much? 2 into 10 to the power minus 7. So it will become 4 into 10 to the power minus 14 upon coefficient of friction 0.25 means 1 by 4. Masses is given 10 gram means 10 into 10 to the power minus 3 into gravitation G. So it will become 10 to the power minus 14. So L square will become 16 to the power minus 14. So 9 minus 14, 10 to the power minus 5, 10 to the power minus 1, so 10 to the power minus 4. So L will become 4, 3, 12 to 10 to the power minus 2. So that is around 12 centimeter. Option number 1. Okay. 12 centimeter. Clear? So let's move to the next question. Four microcoulomb divided into two parts. Distance between them is constant. Magnitude of divided charge, force is maximum. For force maximum, what you will do? Half charges. So 2 microcoulomb and 2 microcoulomb. Okay. That is our answer. We will divide them equally so that force between them will become maximum. Next question. Okay, next question, 21. 3 identical charge balls are suspended from a common point P by silk threads of 2 meter each. They form an equilateral triangle of side 1 meter. Ratio of net force on the charged ball to the force between any two charged ball will be. We need the ratio of net force on a charged ball to the force between any two charged ball. Okay. Okay, so let's see the solution. We have here, let's calculate the net force on this one. So it will apply force in this direction F. Other charge will apply the force in this direction F. Equilateral triangle, so this angle is also 60 degree. So what is the net force here? F and F at angle theta. So resultant will be 2F cos theta by 2, 60 ka half, 30 degree. This is net force divided by force between any of them will be how much? So this distance is 1, 1, 1 divided by F. Between any of them force is how much? F. Net force on this charge is 2F cos 30. So what will be our answer? Tell me fast. Answer will be how much? 2 cos 30 degree. Cos 30 means root 3. So what is our answer? Root 3 is to 1. Okay. Let's see the next question. Move on to the next question. 3-point charges of magnitude 5, 0.16, 0.3. Vertices of right angle triangle. Sides are given AB, BC, CA. Point A is at the right angle. Charge on A experiences how much force? Okay. 5.16.3. We have like this. Five ABC. A is at the right angle. 5.16 and 0.3 microcoulomb. So what they are asking? AB is given AB BC CA 3 root to 3 AB BC 3 root 2. What is the force on charge placed at A? Okay, so this one will repel in this direction. C will repel downward. Let's calculate the value of forces. So here will be how much? K Q1 Q2 5 into 0.16. How much it will become? 0.8. 0.8. Distance is 3. So centimeter, no? Charges are given in microcoulomb, distance in centimeter. Okay. So microcoulomb means 10 power minus 12. Distance in centimeter means 9 into 10 to the power minus 4. K value means 9 into 10 to the power 9. Okay. So let's see, 9 cancel. 10 to the power 4, 13. 10 power minus 13. So it will become 8, I think. So this force is 8 Newton. This downward force will be how much? 9 into 10 to the power 9. Product of charges how much? 5 into 3, 1.5. 10 to the power minus 12 upon distance square. Again 9 into 10 to the power minus 4. So it will come out to be how much? 15 Newton. So what is the net force? Net force will be root over 15 square plus 8 square. So I think it will become 17 Newton. Okay. 15 square, 8 square, 17 Newton. Okay. Next question. Identical tennis ball, mass and charge q, suspended from a fixed point thread L. Equilibrium separation when the thread make a small angle theta with the vertical. When the thread, what is the equilibrium separation when each thread make theta? Okay, so let's see the solution of this problem. Diagram look something like this. Vertical angle how much? Theta, L length. Let's say distance between them is how much? X. Okay, so half distance will be x by 2. So define sine theta. Sine theta will be how much? X by 12. First point. Okay, now in this one, tension T, downward force will be mg, and left side force will be electrostatic. Vertical line, with vertical line it will make angle theta. So tension cos theta balanced by downward force mg, and tension sine theta balanced by electrostatic force. Okay, so tan theta will be balanced by what? Electrostatic by mg. Okay, electrostatic force 1 upon 4 pi epsilon naught q square by distance how much? X square by mg. Now see, they have mentioned one thing, that small angle theta is what? Small. So when theta is small, sin tan theta will approximately be equal to what? Sin theta. So instead of tan theta, what I can write? X by 12 q square upon 4 pi epsilon naught x. This side it will become x cube mg. So what will be the value of x? Q square L upon 2 pi m epsilon naught g power 1 by 3. So this is our answer for this problem. Okay. Okay. Moving to the next. Q divided into two parts. Divided so that certain distance, you know this answer, right? Next problem. Particles AB having charges held at separation 5 cm. At what position third charge be placed so that it does not experience a net force? Concept I have already discussed. You tell me the formula. Direct formula will be, see here, 25. Okay, so they are unlike charges. So for unlike charges, we will look for equilibrium point left or right. So if you are going for left or right, closer to the lesser charge. Lesser charge is 5. So from 5 we will go at distance x and we will look for equilibrium point. X will be given by root 5 upon root 20 minus root 5 into distance between them 5 cm. So root 5 1 upon 2 minus 1 into 5. Answer will come out to be how much? 5 cm from minus 5 Coulomb on the right side. D option. Okay, if you remember this trick point that I told, easily you can solve this question. Moving to the next. Electrons fixed 2D, third point charge proton, midpoint slightly displaced perpendicular to the line joining the charges. Proton will execute SHM of angular frequency. Okay, now this one question I want you to solve it as a homework. If you want to check the solution, what you can do, you can compare it with the previous question of SHM that we did. So where is the SHM question? This one, question number 16. So based on the same approach, you apply this one and you will be able to solve this question. Question number 16. Okay, let's move forward. Question number 26. Okay, so let's move forward. Two small spheres 10 grams suspended from a point by thread. They are equally charged and repel each other to a distance of 0.2. Charge on the each sphere will be. Okay, again this type of questions we are continuously doing, so no problem. Small spheres of mass I am given like this. Threads how much? Half meter long threads are there. Distance, at what distance they are repelling each other? 0.2. So from this half distance will be 0.1. Okay, so again in this one tension will act, downward force will be mg, and this one will force will be kq square by 0.2 square, means 0.04. Okay, so if you talk about tan theta, this angle will be theta, t cos theta will be mg, t sin theta will be this much, electrostatic. So tan theta will be electrostatic by mg. So kq square upon 0.04 mg. Okay, now see, this angle is theta, this angle will also be theta. So this is 0.5, this is 1. So what about this one? So in terms of ratio, we can take this one to be 1, this one is 5, so this one will be 24. So tan theta will be 1 by root 24. Okay. Tan theta defined, tan theta clear or not? 0.5, 0.1. So what ratio you can take? 5 and 1. So this one will be root 24. So accordingly tan theta you can define from there. Equals to 9 into 10 power 9. Charges how much? That's what we need to find. Upon 0.04. Mass, each of them 10 milligram. So 10 into 10 power minus 3 into 10 mg. Charge on each sphere will be. Okay, so after calculation q square will come out to be how much? After calculation it will come out to be 20. Putting this value also compared with q square, so a will come out to be 20. Okay, next question. If you guys are having any doubt in solving any problem, then please put it in the comment section so that I will clarify it further in a separate video. Particle mass 1 milligram, charge q, lying at the midpoint of two stationary particles at distance 2 when each is carrying same charge q. If the free charge particle is displaced from equilibrium position through a distance, particle executes as HM, the angular frequency of the oscillation will be. Okay, important point यहाँ पर you have to remember that. Again, question number 16, based on the same approach, question number 16, you will be able to solve this one. Let's move on to the next question now. Oh, the video is getting lengthy, right? But what we can do, man, you have to work like this only. You have to be motivated with this much of questions. These are the real questions, okay, where you have to sit patiently and solve each of the following questions. Then only your concept will build. Okay, next question. Two identical conducting spheres, negligible volume. Okay, they are brought in contact and then separated by a distance. Electrostatic force acting between them will be. So brought in contact. So what is the total charge? 2 nanocoulomb. So each of them get how much? 1 nanocoulomb at a half distance. So what is the force formula? Where should I write? Here only. Tell me the force between them. So 9 into 10 to the power 9 q square, both are 1 nanocoulomb. So 10 to the power minus 18 upon distance. How much distance they are placed? 0.5. So 0.5 means 1 by 2. So 1 by 4. So it will become 9 4 36 to 10 to the power minus 9 Newton. Okay, 36 into 10 power minus 9 Newton. Next question. Oil drop, radius, density given, stationary under a constant electrostatic force, Milton's oil drop experiment, number of excess electrons on that oil drop. Okay, now I'm going to get with the concept for this oil drop experiment. Numerical value you will solve. Okay, suppose this is the drop. So downward force will be what? mg. So mass will be given by volume into density into g, and that will be balanced by electrostatic force QE. Okay, so in order to be in equilibrium, QE should be equals to V rho g. So what should be the charge value? Charge will be V rho g by electric field, and charge is n into number of electrons. So V rho g by E. So what is the number of excess electrons? So V rho g by E into small e. Okay, volume also you can write. Volume will be 4 by 3 pi r cube. If radius given, you can use this formula to get the value of number of electrons. Okay. So after solving, you will get option number A. Infinite number of point charges, 1 microcoulomb placed along the y-axis, 1, 2, 4, 8. total force of 1 coulomb, the total force on a 1 coulomb charge placed at the origin, the value of x nearest integer. Okay, let's see 1 2 4. On the y-axis we have charge here 1 coulomb, 1 microcoulomb, 1 microcoulomb, 1 meter, then 0 comma 2, 4 0 comma 4, so on 0 comma 8. It will keep on going till infinite. Each of the charge is 1 microcoulomb. Okay, origin also 1 microcoulomb, 1 coulomb charge at the origin, 1 coulomb charge. So let's calculate the force due to each of them. So each of them will repel in this direction. So force will be K Q1 Q2 by R square. This is the formula. Now K, first charge is 1 coulomb, second charge is 1 microcoulomb. It will remain same, 1 by R square. So first one will be 1 plus 1 by 4 plus 1 by 16 plus 1 by 64. Okay, distance is in meter also, no problem. It will go until infinity. So now K, so 9 into 10 to the power 9, 10 to the power minus 6 into this term. What does it form? It forms a geometric progression. Okay, it forms a geometric progression up to infinite series. So this formula is a upon 1 minus common ratio. So 9 into 10 to the power 3, a means first term, upon 1 minus common ratio 1 by 4. 9 into 10 to the power 3, 1 minus 1 by 4, 4 by 3. So how much it will come? 12 into 10 to the power 3 Newton. 12. Okay. Okay. Moving on to the next question. Question number 32. Consider force F on charge Q due to uniformly charged spherical shell R. Uniformly charged spherical shell R, Q distributed uniformly. Which of the following statement is true for F if Q is placed at distance R from the center of the shell? Okay, simple. For x greater than radius, what will be the force? K capital Q small q by R square. Okay, for x less than radius, force should be 0. K capital Q small q by R square for R greater than R. Okay, C option. F greater than 0, no. So which option is there? C option. Okay, it's like, bonus mark question. You can simply solve it without doing anything. Next question. Okay, let's focus on the next question. 2q charge, sphere radius R, density given. Okay, two charges A and B minus q charge placed diametrically opposite at distance A from the center. AB do not experience any force then. Okay, let me explain the question. So the question is something like this. We have total charge how much? 2q. Density of is given as kr. Okay, density is given as kr. Okay, anything else? R is the distance. Okay, so we have from the center we have 2 point charges minus q placed at distance A from the center. So the question they are saying that this minus q, this charges does not experience any force. So what is the relation of A and R? R is the radius. Okay, so first of all let's calculate electric field at this point. Now we can use Gauss theorem for this one. So Gauss theorem says that E electric field into radius A. So electric field into area 4 pi A square, that will be equals to charge inside. So for charge inside, what you will do? You will calculate how much charge is in this much. Okay, so rho into dV, rho dV, from where to where? 0 to A, radius will vary, that will become charge divided by epsilon naught. So into 4 pi A square plus 2 K R, TV will be how much? 4 by 3 pi, so 4 pi r square dr. If you take the volume at r distance, it will be 4 by 3 pi r cube. So if you differentiate it dv, it will be 4 pi r square dr. Important. Okay, so 4 pi r square dr by epsilon naught integral. Okay, so 4 pi cancel. So it will become kr cube dr, kr power 4 upon 4 epsilon naught to fill into a square, putting the limit 0 to a. So E equals to how much? Ka power 4 upon 4 epsilon naught a square. So electric field will be how much? Ka square by 4 epsilon. Okay, this is the electric field due to the charged sphere. This is sphere. At this point, there will be one electric field because of minus q charge. They are repelling each other. So it will be q square upon 4 pi epsilon naught. Distance between them 2a, so 4a square. Okay. So we'll find out that q square upon 4 pi epsilon naught 4a square equal to ka square by 4 epsilon naught. Okay, now we have to find the value of k. This k is not electrostatic constant. Okay, do not confuse it. This is a very good question. So stop it, look for it, solve it step by step. It's a long question, but again important. So density is given kr. So if you integrate this rho dv over the limit 0 to radius is how much? R. Total radius r. Okay, 0 to r. So what you will get? You will get the total charge of the sphere. Now rho is kr, dv is 4 pi r square dr, that is 2q. So k into 4 pi, r power 3 will be there, r power 4 by 4, 0 to r, so it will become capital R, 2q. So what is the value of k here? 2q upon pi r power 4. Now putting it back in this equation, q square upon 16 pi epsilon naught a square will be equal to k value. So k value will be how much? 2q upon pi r power 4 into a square upon 4 epsilon naught. Okay, so see here, pi epsilon naught cancel, 2 2 2 8 will come here, 1q will get cancelled. Okay, I think both charges should get cancelled now. Both charges should get cancelled. Okay, so this one that we have calculated, no, this is what? Field. K square upon 4 epsilon naught is a field. Field multiplied by charge will be the force. So field multiplied by charge here will be there. So here a square q will also be there. So both q's will get cancelled, right? Okay. So what you will get here? See here, a square. So a power 4. One side it will become r power 4 by 8. So a equals to how much? 1 by 8 power minus 1 by 4 times r. 8 power minus 1 by 4 r, and that is our answer. Okay, this is a good question. Again, I'm telling you, it will take a lot of effort. If you don't know this question, simply just leave it and move on to the next simple questions. So 8 power minus 1 by 4 r. Next question, 3 charges respectively 0, d by 2, d from the origin. Net force experienced by plus q placed at x equals to 0 is 0. Then the value of q will be, okay, plus q charge plus q charge d by 2. Net force at the origin is 0, then the value will be q. So now q should be negative only, so it will attract toward this side and this q will positive, so repel. Now force, write down it to capital Q. Q square upon 4 pi epsilon naught, distance between them d square should be equal to, because of this force between capital Q and a small q, so k 1 upon 4 pi epsilon naught, capital Q small q, distance between them d by 2, so d square by 4 is equal. So from there we'll get the value of 4 pi epsilon naught d square, 4 pi epsilon naught d square. Okay, capital Q cancel, so Q equals to how much? Capital Q by 4 with negative sign. So that will be our answer of problem number 34. Okay, moving on to the next question. Okay, man, so let's moving forward. How are you, man? Oh, you guys are with me or not yet? I hope it is there, man. It is physics. Okay, again, best of luck. Keep on putting hard work. That is what it is. No other option apart from hard work. So hard work does not have any supplement, any complement. Charge is distributed within a sphere of radius r with a volume charge density given. Q is the total charge of this distribution, then r is, okay, total charge, a by r square e power minus 2 r by a by r square e power minus 2 r by a, that is our density. So total charge will be integral of rho dv 0 to capital R. Okay, just a minute, let's see now. Rho will be a by r square e power minus 2 r by a dv 4 pi r square dr and 0 to capital R. A by r square, just a minute, better r square cancel, 4 pi a, integrate it, so e power minus 2 r by a. Okay, so what will divide? Minus a by 2, minus a by 2, because that is a coefficient of r, and that will come out. With what limit we have to place? 0 to capital R. Okay, so 2 pi a into small a, taking this one minus, consuming minus inside, limit will change, so lower limit will become higher limit. So first we will put 0, that is 1, and then r minus 2 capital R by a, that is q. So we'll get that q upon 2 pi capital A small a 1 minus e power minus 2 r by a. Okay, so take out this side, minus 2 r by a 1 minus q upon 2 pi capital A small a. Taking log both side, it will become ln of, taking log both side, power will come outside, minus 2 r by a, that will, and this one will become ln of 1 minus q upon 2 pi a small a. Okay, so r will become a by 2, ln minus will be consumed, so it will become 1 upon 1 minus q upon 2 pi capital A small a, and this one will become our answer. Okay, okay. Okay, next question. Bob of a simple pendulum, mass 2 gram, charge 5 coulomb, microcoulomb, rest in a uniform electric field of intensity 200 volt, 2000 volt per meter. At equilibrium, the angle that the pendulum makes with the vertical is, okay, something like this, with the vertical. So this angle will be theta that it is making with the vertical, downward mg, right side QE. So we know that here we have done this multiple times, so tan theta will be how much? QE by mg. So putting this one, Q how much? 5 10 power minus 6, electric field 2000 upon mass 2 into 10 power minus 3 into 10. Okay, so 2 to cancel, 10 power minus 3, 10 power 3 will cancel, 0 0.5, 0 0.5, tan inverse 0 0.5, that is the answer. Okay, okay. Now this one, oh, simple harmonic motion. Why they have given here? Okay, no problem. We'll see this question in SHM chapter. No. Okay, so let's see the next question. We have a metallic ring, uniform charged. AC and BD are mutually perpendicular diameters. So this is AC, this is BD, mutually perpendicular diameters. Electric field due to arc AB to O is E magnitude. Okay, electric field due to part AB. What would be the magnitude of electric field at O due to arc ABC? So due to AB, let's say electric field is E in this direction. Okay, due to whole part ABC, so due to part BC, because of symmetry, it will be in this direction, and this resultant will be how much? E root 2. Second option. Okay, let's see the next question. Infinite identical charge sheets and a charged spherical body of density rho are arranged. Correct relation between the electric fields at A, B and C. A, B, C and D points. Okay, so let's see this question then. Electric field at point A and B. At A and B. Now due to plate, sigma sigma, electric field at A and B will be same, but due to this charge sphere, A and B will be different. Okay, so electric field at A will be more than electric field at B. How I'm writing? Because see, this sigma plate, electric field is sigma by 2 epsilon naught due to infinite sheet. So here electric field does not depend on distance, so this sigma will give equal and opposite, and both will cancel each other. So only because of this charge sphere it will come at A and B. A is closer to this charge sphere, so its density its field will be more. So what we can say about C and D? So C, all of them are repelling in this direction, and D, all of them repelling in this direction. But again for D, when we'll talk about D, so which one will have more electric field? Due to plate, both of them will have same electric field in this direction. C and D both will have same in this direction. Now due to this sphere, you can say that it is closer to D, so D field will be more. So which option you can say that? We can say that option number C is correct. Electric field at A is more than electric field at B, but electric field at C and D are not equal. C and D equal, wrong option. C and D equal, wrong option. C is greater than D. A and B equal, no. So option number C. Got it? Okay, little bit analytical question, so you have to put some focus on this one. Okay, let's see the next question. Here it is saying that electric charge transferred to irregular metallic disc. So there is a metallic disc of irregular shape. Charge transfer densities at different points are given. So we have to see the order. Let's see. Okay, so let's see this one. Sigma proportional to 1 by R. So sigma and radius of curvature are inverse related. So we can say that. Okay, let's see the curvature first. See, curvature at R1 is less. So sigma 1 and R2. Sigma 1 is more than sigma 4 equals to sigma 2. Now sigma 1 and sigma 3, compare these two. Curvature is less at 1 as compared to 3. So sigma 1 will be more than sigma 3 sigma 2 equals to sigma 4. Okay, B option, sigma 1 greater than sigma 2. Sigma 1 greater than sigma 2 बात सही है, it's perfect. Sigma 3 is greater than sigma 4. Sigma 3. So here these two has a more curvature and this one has less curvature. Okay. So we can say that sigma 3 is greater than sigma 4. That's okay. Now see option, sigma 1 greater than sigma 3, right? And that 2 is greater than sigma 4 and sigma 2. So that is also correct option. So which option? A, B, C. Okay. Okay. So moving on to the next question. Assertion: outer body of an aircraft is made up of metal which protects person sitting from the inside from the lightning strikes. Okay. Second point, reason क्या है? Electric field inside the cavity enclosed by conductor is 0. Okay. So statements are true. Outer body of an aircraft is made up of metal. Yes. Protects person sitting from lightning strikes. Yes. Electric field inside cavity is 0. Correct explanation also. Next one. Circular loop that is uniformly charged and has radius a root 2. Find the position along the positive z axis of a Cartesian coordinate where the electric field is maximum if the ring was assumed to be placed in xy plane. So direct answer A by root 2. Okay. Next question. Point charge plus q is placed at the origin. Second point charge plus 9q is placed at d, 0, 0. The point in between them where electric field vanishes. So again simple. We have q and 9q. Where to solve? Okay, no problem. We'll q and 9q at d distance. So we have q charge, we have 9q charge at d distance. So what was the formula? Direct formula, tell me. Both are like charges. So like charges means equilibrium point will be in between and x value will be given by root q upon root 9q plus root q into distance d. So it will become 1 upon 4d. So x equals to how much? D by 4. At what coordinate? D by 4, 0, 0. Okay. Next question. Two charges separated by r at distance x from the charge q, the resultant electric field is 0. Two charges, again same formula will apply. We will get now 1 upon root 3 plus 1 into r upon root 3 plus 1, C option. Next, if net electric field at point P along y axis is 0, then the ratio of q2 by q3 is any question is there here? Oh yes, diagram is given here. Net electric field at a point P along y axis is 0. The ratio of q2 by q3. Net electric field at point P due to q3. So where is q1? Net electric field at point P along y axis is 0. Oh, good question. Along y axis is 0. So along y axis, see here q2 will give in this direction away and q3 will give in this direction. Okay. So E due to 2 and E due to 3. Along the y direction is 0. So see here, if this angle is theta, this angle will be theta. So here will be E2 cos theta. If this angle is alpha, so this component of E3 along this one, now we'll put the value of E2 due to q2 charge, KQ2 distance to 20 square into cos 4 by root 20. E3 will be how much? KQ3 upon distance is 5, so 25 into cos 4 by 5. So 4k cancel, Q2 by Q3, it will become 20 root 20 upon 25 into 5, Q2 by Q3. So 5 4 is 20, 4 into 2 root 5 upon 25 will be written as 5 root 5. So 8 upon 5 root 5. So x value is how much? 5. Okay. The x value will be 5. Next question. Point charge of 10 microcoulomb is placed at the origin. At what location on the x-axis should a charge 40 be placed so that the net electric field 0 at x equals to 2 centimeter? Okay, at what location on the x-axis should a point charge 40 microcoulomb be placed? So 10 microcoulomb at origin, 40 microcoulomb is at distance x, electric field 0 at x equals to 2, at x equals to 2 comma 0. So electric field will be how much? For this one, this distance is 2, so this distance will be x minus 2. So k 10 upon 2 square should be equals to k 40 upon x minus 2 whole square. So k 10 4, 1 by 4 equals to, taking the root, it will be better if I take the root to solve. So it will become 1 by 2 equals to 2 upon x minus 2, x minus 2 equals to 4, so x will come out to be how much? 6. So at what place you will put this one? 6 comma 0, 6 centimeter. Okay, easy. This is like equilibrium problem but with a little twist. Let's see next question. As shown in figure, a point charge Q is placed at the center of conducting spherical shell of inner radii A and outer radii B at the center. Electric field due to charge Q in the different regions. Okay, in region 1 electric field, because Q is here, so electric field will be here, so E1 is not equal to 0. Okay, now E2 since it is inside the metal, so E2 will be 0 and E3 will again be not 0. So E1 0, E1 not 0, E2 0, E3 not 0, option number B. Okay, simple. Move on to the next problem. Oh, itna bada problem. That seems a big man. A thin infinite sheet charge and an infinite line charge of respective densities are placed parallel at 5 meter. P and Q are at 3 by pi meter, 4 by pi meter perpendicular distance from line charge towards the sheet charge. P and Q are the magnitudes. So EP by EQ equals to 4 by A. For 2 times sigma equals to lambda, then the value of A is, okay, let me draw the diagram. We have a infinite wire and then infinite sheet, sigma charge density. So from this we have a distance point P somewhere at point Q. Okay, P 3 by pi, 4 by pi, distance between them 5. Total distance 5 is 3 by pi and distance for the Q is 4 by pi. Okay, so now 2 sigma equals lambda. So 2 sigma equals to lambda, and they are asking 2 sigma equals to lambda, so value of A will be EP by EQ. EP by EQ equals to 4 by A and 2 sigma equals to lambda. What will be the value of A? Okay, let's see electric field at P. Direction they have not given. Plus, both are plus. Okay, so both are plus. So electric field at P upon electric field at Q equals to 4 by A. Let's write down electric field at P. So due to wire, lambda by 2 pi epsilon naught into x 3 by pi, okay, minus due to sigma, it will be sigma by 2 epsilon naught, whole divided by electric field at Q, lambda upon 2 pi epsilon naught into 4 by pi minus sigma by 2 epsilon naught equals to 4 by A. And sigma is given how much? Lambda is given how much? 2 sigma. Okay, so pi cancel, lambda equals to 2 sigma. So 2 sigma upon 6 epsilon naught minus lambda by 2 epsilon naught upon, here again 2 sigma upon 8 epsilon naught minus sigma by 2 epsilon naught 4 by A. So sigma by epsilon naught common, 1 by 3 minus 1 by 2 upon 1 by 4 minus 1 by 2 equals to 4 by A. So 2 minus 1 minus 1 by 6 upon minus 2 by 8, minus minus cancel, 1 by 6 into 4 is to 4 by A. So A will be equal to how much? 6. That is our answer. Okay, important question. Moving to the next question. 2 point charges A and B of magnitude this much, equal and opposite, are placed at distance d apart. Electric field at the middle point between the charge is this much. Distance d between the 2 point charges is, okay, so electric field at midpoint is given. So electric field at midpoint will be how much? Due to both the charges, electric field will be added. Let's say this is plus q, this is minus q. Due to both the charges, electric field will be added. So 2kq upon distance will be half of them, d by 2 whole square, and that is how much? 6.4 into 10 to the power 4. So from here we will get the value 4 to 8 kq upon d square, 6.4 into 10 to the power 4. So what will be the value of d square? 8 into 9 into 10 to the power 9 into electric field 8 into 10 to the power 6, 8 into 10 to the power 6 upon 6.4 into 10 to the power 4. So let's see, 8 8 64, 64 10 to the power minus 1, 10 to the power 3. So this one will come at 10 to the power 6. So t will be how much? 3 into 10 to the power 6. To the power 4 is there. Okay, 9 10 to the power 9, 10 to the power minus 6, sorry, minus 6 is there. So here 10 to the power, how much will remain? 3. Okay, only 3 will remain. So d will be equal to 3. Okay, next question. A very large plane sheet of positive charge is shown. P1 P2 are 2 points at L12 from the charge. Sigma is the surface charge density. The magnitude of electric fields, simple, both electric fields will be how much? Equal. That will be sigma by 2 epsilon naught, because electric field for infinite sheet, large sheet does not depend on distance. Sigma by 2 epsilon naught, E1 E2 will be equal sigma by 2 epsilon naught. Okay, moving towards the next question. So we have scored till now half century. So we have done 50 questions by now. Congratulations those who are continuing at this point. 3 charges are placed at the corners ABC of square A. The magnitude of electric field at the corner D of the square is. So at corner D, Q by 2, Q and Q by 2 are placed at A, B and C. This point is C, this point is D. Okay, the magnitude at D, electric field. So let's see, this one will give in this direction, so this one will be E, this one also will give in this direction E. So writing the value, it will be K Q by 2, K Q by distance square, X or A square. Okay, now when you write it for the B, it will become how much? K Q by distance 2A square. So K Q by 2A square, all of them will become E, E and E. So three vectors are there, E 90 degree, so resultant E root 2 and then plus E in the same direction. So it will become E times root 2 plus 1. Okay, now E value 1 upon 4 pi epsilon naught Q by 2A square. So when you take 2 here, it will become 1 by root 2 plus 1 by 2. Option number A. Okay, vector directions of electric field, simple. Next question. Oil drop radius 2 mm, density 3 gram is held stationary under constant millicons number of excess electron. So this type of question we have already done. So you can go and check the question. So it is similar to question number 30. So check question number 30 and you would be able to solve this one. Next question. Uniformly charged disk radius r, surface charge density sigma, placed in what? XY plane with the center Earth. Find the electric field along the z axis at distance z. Uniformly charged disk. Okay, so this is uniformly charged disk of disk sigma, center at origin. Okay, along the z axis. Okay, so electric field due to disk formula is sigma by 2 epsilon naught into 1 minus cos theta. So when you join it with this circumference to this point, angle will be theta, so cos theta will be r by root over r square plus z square. Sigma by 2 epsilon naught 1 minus, sorry, cos theta, no, z. It will become z upon root over r square plus z square. Option number B. Okay, so let's see the next question. What will be the magnitude of electric field at point O as shown in figure? Each side of the figure is L and perpendicular to each other. Okay, so each side is L length only, perpendicular. Okay, wow. Now 2Q will give in this direction and Q will give in this direction. So due to this one, we will get downward how much? K. This one is 2 times of this one. So KQ by L square, downward net electric field. Okay, due to C and F. Now due to B and G, again 2Q. So in this direction we will have how much? KQ by L square. Now comes H, so, and A. This one Q, minus Q and minus Q. So A and H same center, so they will give no field. Their field will cancel. Now this one again 2Q and this one again 1Q. So 1Q will cancel. So K Q square, oh, 2Q whole square. Gone again. What? Oh, sorry. So this field will be how much? K 2Q upon L root 2 square. So 2L square minus field to D1, it will be KQ upon 2L square. So KQ upon 2L square will be the net field. Okay, now let's see. So we have KQ by L square left side, KQ by L square downside. So the resultant will come this side, KQ by L square root 2, and this one along opposite to that side comes KQ by 2L square. So which one is more? Root 2 is more. So downward electric field will be KQ by L square root 2 minus 1 by 2. That will be our answer to this problem. Okay. Okay. root 2 minus 1 by 2, option number 1. Next question. We have rod AB is bent 120-degree circular arc. Charge minus Q uniformly distributed over AB. What is the electric field at the center of curvature O? So electric field of the center. So electric field formula is given as 2k lambda by r sine theta by 2. Due to circular arc, this is a direct formula that you can remember. 2k lambda by r sine theta by 2. Okay. So 2 by 4 pi epsilon naught. Now charge was given how much? Q. So it will give electric field towards this direction, that is for sure. AB is negative charge, so it will give towards, so I cap. So direction no problem. Charge upon r into theta. Charge per unit length. Lambda I am defining lambda. So lambda is charge per unit length. So charge and length is r into angle. So angle is how much? 120 degree. So pi by 2 pi by 3. So 2 pi by 3 lambda then, and then r sine theta by 2 means sine 60 degree. Sine 60 root 3 by 2. Okay. So these two cancel. 8. So root 3 by 8 will come. Q upon pi square epsilon naught r square. Which option? 3 will also jump upward. No, this 3 will jump upward. It will become 3 root 3 q upon 8 pi square epsilon naught r square. Option number B. Okay. Practice this formula a few more time and you will be good with this. Circular arc. Field at the center due to circular arc. Distribution must be uniform. Then only this formula is valid. 2k lambda by r sine theta by 2. Okay. Next question. Two infinite planes, each with uniform surface charge density plus sigma, are kept in such a way angle between them is 30 degree. The electric field in the region between them is given by. Okay. So at any point, if you talk about electric field due to this plus, it will be in this direction, sigma by 2 epsilon naught, and due to this one, it will be in this direction, perpendicular to the rod. Okay. If you draw this one, so this is 90 degree. Okay, this is 90 degree. So this angle will be how much? 60 degree. So this angle also 60 degree. Okay. So we got electric field now. So see, it is sigma by 2 epsilon naught. Take the component in this direction. Let me draw it separately. So upward component is sigma by 2 epsilon naught. Now this component will be sigma by 2 epsilon naught into a cos of 60. Cos 60 is sine 30. And this one will be sigma by 2 epsilon naught sine of 60 degree. Sine of 60 degree is root 3 by 2. So tell me which option? Sigma by 2 epsilon naught or root 3, 1 minus in y direction. It will be 1 minus root 3 by 2. Okay, 1 minus root 3 by 2 into y cap. And then in x, sigma by 2 epsilon naught common, 1 by 2 will remain. Sigma by 2 common, 1 by 2 will remain towards the negative. So option number A. Okay. Next question. Charges Q1, Q2 are at points A and B of right angle triangle OAB. OAB right angle triangle. The resultant electric field at O is perpendicular to the hypotenuse. Okay. Resultant electric field is perpendicular to hypotenuse. Let's see. So due to Q1 it will be downward electric field 1. Due to Q2 it will be this direction E2. Now if you draw the perpendicular here, so along this direction it should come. Okay. So if you take this angle theta, so this angle will also be theta. So what about this angle? It will be 90 minus theta. So if you define tan of 90 minus theta, tan of 90 minus theta, it will be x1 by x2. So that is cot theta. So tan theta will become how much? X2 by x1. This is our equation number 1. We will use it. Okay. Now electric field 1 is how much? So we can say that from this triangle, From electric field magnitudes, tan theta we can define. So tan theta will be E1 by E2. E1 is how much? K Q1 by X1 square upon E2 K Q2 by X2 square, and tan theta is how much? X2 by X1. So K cancel. So we'll get here Q1 by Q2 into X2 by X1 whole square. So what is the value of Q1 by Q2? It will be X1 by X2. X1 by X2, option number C. Okay. Moving forward to the next question. Two charged thin infinite plane sheets, sigma minus sigma. Sigma is more than minus sigma.